In this video, we're going to discuss electromagnets and electromagnetic devices. This is our second part in our three-part magnetism series. Make sure that you're completing the electromagnetics notes part 2 along with this presentation. Our first topic is Faraday's law. Faraday's law is the moving of a strong magnet through a coil of wire, and this creates an electric current. You can see a magnet moving in and out of this coil of wire. As we move this in and out, we see that our voltage increases and decreases. We are creating electric current just by moving a magnet through wires. The opposite of this theory is a solenoid. In this case, a coil of wire carrying current produces a magnetic field. And this can be as strong as a bar magnet. We use this theory of a solenoid to power many different things that you use every single day, and we're going to talk a little bit more about this. If we take a solenoid and add an iron core, here we have added an iron nail. We still have a coil of wire wrapped around it attached to a battery, and we're going to create a magnetic field. This is actually pretty easy to make. Hopefully we'll get time to make one of these in class. If not, I'll be happy to show you how to make one of these at home. And it can be strong enough to pick up a good number of paper clips. Changing the current controls the strength and the direction of its magnetic field. The strength itself depends on the number of loops, so how many coils you have, the amount of current, how strong your battery is that you're powering, and the type of core, what you actually wrap those coils around. We use electromagnetic theory and electromagnetic pieces to use different devices. On the back of your notes, you're going to see a table with 3 devices. The first example is a galvanometer. And you already see the picture, something similar to this picture that you see here. And you see the name. Please, in the blank box, add these notes. So a galvanometer uses a solenoid to measure small amounts of current. An example here would be your car's fuel gauge. It's actually a measure of current that changes you from full to empty. Our next device is an electric motor. An electric motor uses an electromagnet to spin an axle. Our last device is a loudspeaker. In a loudspeaker, a solenoid is placed around one pole of a permanent magnet. Changing the current, reversing the direction one way or the other, changes the magnetic field, and the magnetic field changing, attracting from positive to negative, moves the coil, and this vibration produces sound waves. This is how a loudspeaker works. So right now, you should be able to explain what Faraday's law is, be able to tell the difference between an electromagnet and a solenoid, be able to give how we create both of them, be able to tell the difference between these 3 types of electromagnetic devices: galvanometer, electric motor, and a loudspeaker. At this point, please open up on the class website the link to the PhET simulation on Faraday's law, And please explore Faraday's law a little bit more with the help of the worksheet that is also with this day's stuff.